Okay, my wonderful friends, today we're going to look at the moon and we're going to discover what the reason the moon rang like a bell. I think it was in 2010, somewhere around there. They went up there and they dropped a stage of the rocket onto the moon, and then they watched it pulsate. It vibrated, and they say it rang like a bell. Well, I'm going to tell you something. It did not ring like a bell. It rang like a bowl of jelly. Now, we're going to look into what actually did happen then, and my explanation for it, and what their explanation for it is. So let's get started. This is going to be about the moon and how it's built and what it's made out of. And I showed the moon, I think, pretty well. And it's biological. There's virtually, in my mind, no question whatsoever. And I don't think anybody that's seen my video can question that either. They did ask why it rang like a bell. That's what we're going to talk about today. All right, I'm going to just read this to you. This was during Apollo 12 mission, 1969. Astronauts conducted an experiment involved deliberately impacting the moon's surface with a spent rocket stage. All right, so they completed their mission and they sent this third stage of the Saturn V rocket into the moon's surface. The impact of the rocket was strong enough to generate seismic waves, which were recorded by seismometers. They record the vibration. It had been placed on the moon's surface by the astronauts as part of their scientific experiments. Now, so they're saying they landed on the moon, put these things on the moon, and they picked up these vibrations. Let's just go with that. Don't start arguing that kind of stuff here, please. Let's just go with what they said and see if we can make sense of it. Now, the resulting seismic waves caused the moon to vibrate extended period, which led some scientists to describe the moon as ringing like a bell. Well, no, it didn't ring like a bell. It did vibrate. Now, the frequency, this is the key. What was the frequency? 5 hertz. 5 vibrations per second. Ringing lasted much longer than would expected by an Earth-like object. The seismic waves reverberated for several hours, indicating the moon's interior has a unique structure compared to Earth. Well, they don't know what's inside the Earth either, but let's just say they're right. The explanation. The moon doesn't have a liquid core like Earth. Who says Earth's got a liquid core? Its interior is much more rigid. This caused the seismic waves to propagate through the moon's body in unusual ways, creating vibrations that were sustained for an unusual long time. The ringing does not mean the moon is hollow, as sometimes imagined in popular myth, but rather it suggests that the moon's interior is partially rigid. Now listen to this carefully. Partially rigid with some degree of porosity. Partially rigid, stolid, but there's holes and there's a way for it to vibrate. Now it says the moon likely has a relatively small and dense core. I can agree with that, possibly, which with much of its interior being more solid than Earth. Well, they don't know what's inside of Earth. I can't believe they keep make all these statements about, well, we know this, we know that. No, they don't. They don't have any idea about any of this stuff. Scientific implications. The data collected helps scientists learn more about the structure of the moon's interior. Now listen to this. Including the fact the moon has a very thin crust. Remember that, very thin crust and a small, dense core. Possible. The long-lasting seismic waves were used to model the moon's interior composition and provide insights into its geological history. They want to know, how did the moon develop? What's its geological history? How did it turn out to be the way it is? Here's their conclusion. When the moon rang like a bell after Apollo 12 rocket impact, it vibrated a frequency of 5 hertz, 5 times a second. Vibrations persisted for several hours, which helped scientists better understand the moon's interior structure. I don't think so. This is not an indication the moon is hollow, but rather it has a unique, somewhat porous structure, allows seismic waves to reverberate longer periods than on Earth. similar to a bowl of jello. Okay, so what does a bell ring at? The ringing of the moon and the ringing of bells. A bell typically rings in the range of 100 vibrations to 2,000, depending upon the size and the type. The moon's ringing was only 5 hertz. Way, way, way different. All right, so that's, one is metal and the other one is jello. That's going, that's it. All right, just so that we understand where I'm coming from, I posted about the heat radiation from a huge mass under the moon's surface. And then I went on to say what I believe the moon is made of. Now here's what they say, and this was just a couple of days ago, and discovering and uncovering a lunar heat. They say, where did heat come from? Heat is emitted from granite mass. They have no idea what it's emitted from. They're just guessing that. Beneath the moon's surface. How do they know that? If it's beneath the moon's surface, there's no way they can figure out. This is what they speculate. Specifically near the Compton and Belkovich craters on its far side. Well, those two craters are biological, and it's emitting heat because it's decomposing. Okay, remember these words. The moon has a very thin crust. I would call that a membrane. And then it has a lower membrane, and then it has another membrane. And then it has these two holes here. One of them has a valve in it, and one of them does not. This is the far side of the moon. I claim this is biological, and I claim this is a tendon enthesis. What is a tendon enthesis? Let me show you. And I also claim that there is nothing but biology, and most of the moons I have found are tendon enthesis. They're different styles. There's a whole ton of them. Wait till you see the different ones I can show you. You're going to flip out. All right, those two spots I just showed you here, this is the same, this is the moon. Now, just stop and think for a second. This is a thin membrane, and it is a membrane coating a tendon enthesis. And they have layers of membrane, several layers, before you get to the inside. And then the inside has a bunch of more layers, which I'm going to show you in a second. But it has to be fed with blood, and it has to go in and come back out. Here's where it goes in, here's where it comes back out. Artery, vein. Nothing here is not understood. It's fully, completely, totally understood. This is what a tendon enthesis is. It has all these wrinkly, dimply spots just like this. This is mimus. It's a moon. These are the artery and the vein coming into it. When they break off, they create this scale around it, and they come right off. The same thing on the moon. Snap! The whole cord came off. And it's just what happens. It happens a lot. Now, I said the moons have different shapes because some are different styles of enthesis. You have certain ones that are a ponerosis tendon, you have rope-style tendon, you have the little tiny investments that go into the bone and into the everywhere in your body. Everything that anchors has one of these balls. And when I say anchors, you got thousands, hundreds of thousands, literally, I'm not kidding you, hundreds and hundreds of thousands of these balls in your body. Hundreds of thousands, maybe millions. Okay, here's another moon. This is Tetris, and I believe this was the tendon emplacement in this one. All right, see the same pattern here? Now don't forget, I'm showing you got a vein and an artery with that cord going in. Our moon is completely round, but there's other ones that have an equatorial ridge, which is Iapetus, another moon, but it has this equatorial ridge. What caused that? They have no explanation whatsoever for these things. None. They just regard, don't show us those kind of things. We have no explanation. Well, let's try to figure one out. You see these little ridges here? Watch this. They're all over Earth, too. This is a tendon ball. That's a tendon, I call them tendon ball. Tendon enthesis. Enthesis just means that's at the end of a tendon. And guess what else? Here's one right here on Earth in a wall of muscle. And guess what that is? And guess what that is? All right, you Mudfossil people, you with me? Do you know what they are? Of course you do. They're artery and vein, red and black. And that, my friends, is a tendon enthesis. And this is on Earth, in a wall. And this guy's looking at it and saying, what the hell is that? Well, I know what it is. It has the two things coming in, just like our moon, or this one, or Iapetus, or Mimas, or Tetris, or any of them. They're all the same. They all have, and even Io. I don't know what's going on with Io. This is something to really look into deeply, because I don't know anything about Io at this point, other than it's pretty strange looking. All right, so I'm going to show you some pictures that are going to blow you away. Everything there is biology, and some of it was stupendously enormous. The Titans were real. They are in the earth in those days, and still are in the earth in these days. And then there were more giants after the earth was assembled of Titans. And those were the ones that were the sons of God went into the daughters of man. All of that stuff is written, is true. I don't care. Nobody can convince me of anything anymore. I can see what I see with my eyes, and academia is a disgrace to education. It's a real serious problem, and I hope Trump does something about this. I'm fighting like hell to see that it gets taken care of. And there's a lot of other issues that I can help, because we've just been basically defrauded by everything. Academia, right on down. NASA, Fermi Lab. It's nothing about funding, and it's nothing for us. It's all about them. An honest academia would be looking for answers. I have all kinds of, I get DNA tested things. I have lungs that came through space. That's an iron lung right there, a tiny little iron lung. Came through space, it's magnetic, and it's still got blood in it. This can be tested. Refusal to examine anything. And last night I was watching 60 Minutes. They said it's just become an echo chamber. Colleges are a waste of time. They're a disgrace to America, an absolute disgrace. For 15 years, the most disgraceful group of people I have ever seen in my life. I'm telling you, I'm just fed up with this. I'm really, really getting frustrated as hell. The only chance we got to get out of this absolute nonsense and lying frauds that are destroying our world is hopefully Trump can do something about this. I'm not a big political guy. I don't like any of them, to be honest with you. But he's as close to somebody that can do something as I've seen. Not a single one of the other ones care a bit about us whatsoever that I can see. None. Zero. It's all about, I'm not going to go down this route anymore. I'm fed up. I'm sick and tired of it. Well, okay, my friends, sorry about my outburst, but we need to change things. Let's just leave it at that. You see this? This is the hardness scale, from soft to harder and harder and harder, all the way up to diamond. And these are all the different colors of primarily transition metals. But you're going to see silicon dioxide, silicon, 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 silicon. Everything basically has silicon until you get up here in this alexandrite, ruby, sapphire, and diamond. They're a little bit different, but they're all crystals. And these colors are transition metals. Now, I have a finger here that has, and all of these are products of blood. I'm going to tell you that right now. As we look at this finger, I'll explain to you why they're the product of blood. Okay, do you see all these different colors of gemstones? These are all different transition metals that bonded with something to create these colors. I'm going to show you transition metals, then I'm going to show you a fingertip that the blood ran out and it had all of these transition metals in it, so it has all these colors. I'll show you that in a second. All right, once again, you have to understand chemistry. These are the transition metals. Hold on a second. And they're primarily they are in this section here, transition metals, but then some of the other ones, they're called other metals and metalloids and so forth. They are in your blood. They're in your blood, and they form these different colors because of these states of charge. 3, 2, 4, 5, 6, 7. They're all different charges, and they're in different orbital So they bond with different things. Just remember it this way. These carry things through your body. These are carriers. And they lock on, and the metal core is this. So this is titanium. Here it is in the center. Well, it's got a +3, which means it wants to attach to something. All right, so things come and they're called ligands. They're called ligands. They attach to the metal ion. Click. And then it goes through your body, through this aqueous solution, which is the watery stuff in your body, and the ions form complexes with these colors. So they have these colored complexes. But then they dump off some of this stuff, and then they come back to get recharged. Just think of it that way. These are the things that I am going to show you right now, these colors. And you can find them in, I have lungs. Well, let me just show you what I have real quick in the microscope. All right, I got this in the microscope, this little tiny finger. These are all the transition metals. Now, this is going to be a little focusing, a little playing around with the microscope, so stick with me. But you see what you're seeing there? I'm going to start pointing things out. Like I said, this is going to take a minute or two. All right, here's what we got. This is the bottom of a finger, and it died laying like this, and the finger was down this way. This is blood, and this is the blood under the bottom of the finger. Now, I am going to start moving it around so you can see. It's about the size of maybe a little smaller than mine, maybe a kid's size finger. Now, plus, you see all these straps and things down here? Let me dry it up, hold on. A little too much water on there. Now, you see all these straps and things down here? You see those? That's caused from grip skin. Very, very tough stuff. Now, all of this reddish looking stuff, that's blood. And it ran down from the tip. Now, I'm going to turn it over to the fingernail side. All right, and there's the fingernail side. And it was tipped in this direction like this, and the blood ran down and created this blood bubble at the end. Now I'm going to secure this so you can see it without jiggling it around. Alright, now I'm going to come pretty down close so that we can see these different colors. Now you see the best colors when you screw around with the light. But you see that? That's coming right out of the tip of that finger. Now let me back down the light a little bit. You see those colors? Look at that. There's every color you can think of in there. And you should see the lungs, which you will in a moment. You see these different colors? That's all different blood chemistry. Because this is just blood coming right out of the tip of that finger. And there's a pretty good little red one here. I don't know. Could be ruby. I don't know what it is. There it is right at the bottom. Hold on. And like I say, this takes time because you got to jiggle around. Oh, I see it right now. There it is, that little round bubble. There we go. That's it right there. But look at all the colors around here. And I'm sure there's gold in here too, because gold is in your blood as well. Now, I'm going to turn the lights down. When you get way down, you can actually see the gold and stuff, which I think that might be gold right there. But you see all the different colors show up as you get lower and lower in the light. These are all little bits of gold. I'm almost certain of that. And then the light's out. Okay, so here we go with almost no light. A little more light, a little more, 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 a little more. And we start to see all these different colors. And that's, now, in a huge, gigantic creature, that ball would turn into a big ball of crystal. I mean, it would be big, and they could make huge, gorgeous-looking crystals out of it. That's how they had all those gemstones I showed you. Those are nothing more than blood that congealed. All right, here's where it comes in that you need to understand anatomy. This is that fingertip. This is the fingernail. And you look at, oh, that could be a fingernail. It could be anything. This could be anything, just something glued on there. Well, you see these little holes here? This is what's called the apical tuft at the end of your fingertip. And there's a ball right on the very end, and then there's a big thing like this with a whole batch of holes in it. And that's this right here. Now, I have one here from a giant that is completely eroded away, and all it has left is the apical tuft, and it broke away from the fingertip. This is just amazing. Look at how identical this is. It's identical. That's the ball right there. See the ball? These holes are exactly aligned in the exact same places. All right, and then from there comes down your fingertip. But all your tendons anchor right into these balls right under your fingertip right here. That way there you can do all these kind of things, and they have the gripping power to pull and so forth out of here. And that is an apical tuft. Now this, of course, is from a giant. That's from something our size. Okay, my friends, so in the microscope I have a small lung, which is a mud fossil. Now, we're going to look at that in the microscope. And you say, well, Roger, I can't see anything. Oh, there's no colors there. Well, there is, but you do not see them. However, you will in a moment. Here, the dull-looking colors are blood. All right, that's blood that is running through these alveoli. And you say, what alveoli? They just look like little mirrors. Well, that's because I have it facing directly down and the light is flashing directly back at us. If I turn this just a smidge, watch what happens. Boom. Look at the colors. Look at the colors. Now I can make it flat like that and just shine it through it. It's polished, obviously. Now those are all the same colors that are in the blood. Look at it. Hold on, let me turn up the light a little bit. You can play around with the light and jiggle it around here and there, but all of those are different crystal solutions, and they grow what they call seed crystals. Will start in there and they'll just keep growing and growing and growing, attached to whatever they like best, if they can get it. And in the mud fossil situation, it was nucleophilic invasion and substitution, because it stayed wet in these extreme silicate. And this is silicates that have invaded this. That's why I showed you the SiO2. It's quartz, silicon dioxide, but it has inclusions, which are the transition metals, and they are from the blood, and they invade and start to grow these different little sections that'll be all different colors. So that's a cut open lung. All right, I'm going to show you another little tiny lung. And some lungs stay completely, totally covered with pleura, just like they're perfect. And I mean, they're saturated with blood. I had this DNA tested. It's human. And it's flat as a pancake on one side. And virtually all my mud fossils have a flat side, most of them. Now this one here is completely denuded of all of that pleura. It's all the way down to the alveoli, as is this one. Now this one has all its colors in it. It's not a human lung, I don't think. But that's where the plumbing comes in on the side, just like this right here. And that's what that lung looks like. Now, remember I talk about the spurlock all the time? There it is right there. There it is. It's because it's a whole different material than the rest of the lung. It's not like the rest of the lung. And it's on this one too. It's on this one too. It's on all of them. Every lung has this spurlock on it to lock it in place so it can rock around in the body and do all those things but stay attached. And this has these little tubes. You probably can't see them, but there's little tubes coming out of here. Here's another one with a spur lock. You see that? There's a spur lock right there. You probably have a hard time understanding that with this one. But the lock comes down here. The rest goes back here to the really thin fascia that's, they call it silver skin, or it's just the really membrane fascia. Here is where it locks in, and that's why I call it the spur lock. And right there is where it's tough as hell. And right down there is where the fluids pass to the next organ. Same with this one. Same thing here. Tough, tough, tough. Very tough. And very, see those little tubes coming down? All right, now we're going to look at this in a microscope, and I'll show you. This has all the same colors as the other one. It's not as polished as the other one because I polished it. That's why you see a lot of, but you'll see colors. Could you even see that? Maybe not. Oh, I think you could. Hold on. All right, this is the little lung, and we're looking at where the tubing would have gone inside. And I have it in the microscope up above, all right? Now, and don't forget, the tubing comes in right in the side, which is where we're going to be looking at. And I got it laying like this, so we're going to be looking down into that cavity there. All right, now, they turn real gooey, so they sort of plug up all these places, but that right there is exactly where it should be, and that is it right there. That's the entrance. However, it would have been this big around. Now let me see if I can focus this a little better. It would have been all the way around here. And it's just crystallized. But that's, you can see a hole right there. Now, I'm going to come back out of here and show you what this thing looks like as we come away. Now you can, hold on, let me lock it down here for a second. This whole area is where all the blood came in. Well, air basically. You see how it's different? You got to look for these subtle things, but this is it, right? And it's right, it's exactly where it should be. It's in the pocket of the lung, which is right there, as I will show you in a minute. So that was the entry tube. Now, remember I showed you, I talked about the spur lock and all these different colors. Look at the colors on this. Now, it's not polished, so you don't see them shiny looking, but they are certainly there. I probably should get the polisher out and just polish a couple spots on here, just so you can see. But every one of these basically was an alveoli. Now, I made mud fossils, and one of them is very similar to this. You see down here it's dry, you really can't see a whole lot. You put a little moisture on it, you can see a lot better. Anyway, right where my finger is right there is a cavity, and that's where the long tubing went into. I'm going to do a catalase test on this. I can guarantee you, almost as certainly, there'll be a lot of catalase reaction. You use hydrogen peroxide. That has an extra oxygen. It's going to bond with all this. I can see this stuff is highly biological. I can see no reason whatsoever we shouldn't get a very strong catalase reaction right where the tubing is, because that's the tube that ran in. We should see real good here, and I hope to see the fuzzy stuff around the outside. This is going to be fun. This is the ones I like. And of course, this is just drying out because it's not gooey wet with blood. The whole thing was wet the same way. This bloody tissue and moist, well, it doesn't have to be moist. It just has to have a lot of blood. a lot of the red blood, artery blood, which this does. And what that does is it just sucks water right up like unbelievable. If I showed you this right down here, remember this down here? And I should show you this on a microscope. If you put water on here, down here within 10 seconds, it's going to be dry again. 10 seconds. It will very quick, let's put it that way. And it will absorb that and literally turn back into blood. I'm not kidding you. It'll literally turn black into blood. Just like this one here. This is the blood, actual literal blood. Bubbles of literal bubble in blood. Bubble in blood. And where did that bubble in blood came from? It came from there. That little lung. And this died laying like this. This red collected all of that water. I mean, all that blood at the bottom, and was probably buried to here. I don't know. This goes back a lot of years. I've been doing this, so I can't remember where I got that from. Everything's starting to turn into a blur. That happens when you get my age. Now, let's go back up to the lung that's in the microscope. Here's the one that's in the microscope. Now, here it is again, and you can still see it's still got some moisture to it. They dry up pretty quick, but you can see it does. Now we're going to put some of the hydrogen peroxide on there and see how serious a reaction we can get. I'm going to have to get a lot closer to this and probably turn the lights a little lower so that we can see more reactivity, focus it in. But in the meantime, I'm going to hose it down because it's a real bucket. I'm going to just put a puddle of hydrogen peroxide on here, and this should literally explode, I would think. I'm way, way, way off now. All right, we're going to get way, 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 way down close. So let's get ready to do the test. Okay, here we go. I'm just going to put a couple of drops right in that spot. All right. Now I'm going to slurp it around a little bit. All right, now. It's going to be real reflective, but we should see a lot of bubbling going on, which I can tell that's going to happen. Now, let me come right down on top of it. And again, it's going to be real shiny because it's got a reflective surface. It's going to have to work its way in, it looks like. You see the bubbling? Now let's just sit here for a minute, because it takes a while for that stuff to get in and do its invasion. But you see where it is right now? This is inside of this lung. All right. It's taken a while. I may have to put some more in there too, because the first batch of it just sucks it right up. But you can see all those little bubbles. The only reason those bubbles are coming out is because there's what's called catalase, an enzyme, and it cleaves off one of the oxygens from the hydrogen peroxide, which has two oxygens. It's only supposed to have one. H2, which is two hydrogens, and O is water, H2 and one O. Hydrogen is H2 and two O's. And this breaks off one of the O's, and it is a gas. Oxygen, as you know, is a gas. Now, I'm going to play around here and see if I can find a really good reactive spot, which will be a membrane. That's where you get the really good reaction. Hold on. I got to be honest with you, I'm stunned. You saw that first catalase reaction was, you know, semi-strong. But I had expected to really see some serious reaction, and I am not seeing it. I'm seeing almost no bubbling at all. There was the initial bubbling. But that was just related to the surface, it looks like to me. We should be seeing things coming out of here, bubbling up right now in, you know, copious quantities, and we're not seeing any of that. You can see all of the different crystals. I don't know what to think. Well, wait a minute here. Right next to that, this one here. Right down there, that's the kind of fuzz. But boy, I tell you, you got to be close, and I can't get any closer than that. It's just a terrible reaction. I'm literally shocked. But that's what research is all about. You get an idea and you say, oh, and then all of a sudden you say, ooh, I was not correct. Well, I'll tell you, that's amazing. I can see biology everywhere. And virtually no catalase. Very interesting. Extremely interesting. And I mean, it's not here anywhere. There was just a little bit, but I think that was just surface stuff. There's nothing bubbling up out of here. Wow. It's shocking. I am shocked, and I do not shock as easily as the average shock-e. I mean, there's no question there's biology everywhere. But that should be bubbling out of there with enzymes of cutting into the oxygen. Just not happening. But anyway, this proves, well, I don't know if it proves it to you, it certainly proves it to me, that these lungs have all of these different transition metals in them. And when you find gemstones, they're these kind of things. Transition metals that have concreted and joined with each other to form crystals. They have certain preferences, certain polarities that attract to each other, and that's how they form these crystal formations, and they just keep growing, growing, grow. Now this is a very small lung, but if it was a huge lung, that could be the size of a house. Who knows? All of these different things are going to have a different size to them. I'm telling you, I am shocked. Now, could it have eaten it up and brought it down inside? Let's try this one more time. I can't believe this. Okay, it's official. There's virtually no reaction here. I could see the tiniest little bit of fuzziness right there. But I mean, you can't claim anything from this whatsoever. Nothing. But if you look right at that spot right there, you can see a little buzzing. See that? That's the indication of a membrane being right there. Membranes fuzz like that. But that's basically the only place I could find. I looked all over. So, you know, I mean, it is a lung. I'm positive of that, but how all of the catalase got removed, I don't know. All right, so now we've gone through the chemistry and the reactions and the moons and all this stuff. I'm going to show you stone balls that are all different, so we could get any kind of a vibration coming back. You saw that some of them have equatorial ridges. Some of them don't. Some of them, I mean, they're different styles of tendon balls, and I'll show you that is a fact. Mimas, Tetchus, Iapetus, Our Moon, Io. As far as I can determine, they're all biology, and I'm pretty sure everything is biology. All right, I got so many pictures of different types of stone balls. We're going to do it this way. I'm just going to run right down the list. Now, they're all over. You see them all the way down the coast, and they have eroded from a creature that was like up here, and it's all eroded and laying on the beach. Now, the next one here is facing stone. I don't know what about this, but this was long before AI, so that's the face, Rongo stone. I don't know about that, but who knows? All right, stone ball. You see this? Here's one of the styles. It's just like an eggshell. It has, or like a Russian doll or whatever they call it. So now, how would that ring if you popped that? And it was not hard like stone, because the things in space, they're not like stone. The stuff that came through space, my little meteorite lung right here, still has wet, really red blood in it. And things coming out of space come into Earth with still blood in them. And I could show you other meteorites that still had blood in them when they came into the, so out in space, they're gonna, the outside of it is gonna toast off, yes, because of the extreme ionization of particles. There's nothing to block it. Bam, they hit it hard. But they're only gonna go so deep. Now this, as far as I'm concerned, it looks to me like all these meteorite showers and meteors and all these kind of things that are in space could very well have happened when Venus actually hit Mercury. I'm sorry. Venus hit Mars. And this is all recorded in the ancient texts. And you can see the scars. That Mars Marianas Trench or whatever they call it. This thing's wider than the United States. And there's a huge, gigantic electrical discharge scar on Venus from where it hit. And the ancient text said that a fiery comet hit our atmosphere and caused the Great Flood, and a salacious ooze from under the oceans came up and flooded the whole world with the silicon, which caused everything to harden up into stone, the mud fossils. Everything you see is feldspar, basically, and it's aluminum silicates. Aluminum silicates, just look it up. Look up feldspar. 60% of the crust is covered with this feldspar because there's all membranes. Aluminum silicates were part from the phospholipids. The phospholipids, phosphorus, which is all the membranes, boiled down to aluminum silicates during the great boiling flood event, because Venus almost hit Earth, it boiled the oceans, and that's what created all of these feldspars. I called it fascia, which is the phosphorus. Fascia facilitated fossilization. And this is what caused the mud fossils. Now, there's one style right there, so enough of that guy. And here's another one. Whoops, that's the same guy. These are cutting stones. I put in a stone, so anything that comes up with a stone, we're going to be seeing it. Whatever they are cutting here, whatever this was from, je ne sais pas, I do not know. All right, somebody played around with this, I think. This is not, I can't believe, well, I don't know. I don't know enough about this. It's called soft stone. Now, how somebody did that, once again, I do not know. These are some balls, and you see how they have little attachments too. They're all over the place. When they're out there, they're just everywhere. There's not just one or two of them. They're everywhere. You see, there's one here, there's one over here, there's one over here, up here. This is in skin. This is like kaolin clays, bentonite clays. It's a finish clay, and they're different colors because people came in different colors. Creatures came in different colors. Skin came in different colors. This is a red-skinned creature, looks like to me. And they're all different colors. And these are the ones that have the cracks in them. Now, the cracks are caused by iron banding. And what happens is the black and the red blood, which is the vein and the artery blood, push each other away. And they just actually separate and crack these balls. So inside of here, these are dense with iron. And I have one here that's, I don't know if it was a ball or whether it was a lung, and it did the same thing as this. Hold on a second. You see, this is basically the same thing. Now, why do they crack like that? That's kind of unusual. Why all these little splits? And I can show you why right here. And I'll put this in a microscope and show you. This side is one type of blood, and the other side is the red blood. So you got the black magnetite, magnetite pushing the hematite away because they're two different oxygen states, and they don't like to be touching to each other. So you get them all crack, 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 crack. They call it iron banding. And they make these seams, the black and the red, the black and the red, the black and the red, straight down the line. All right, this is what creates iron banding right here. The black is the vein blood and the red is the artery blood. Two different states of iron. And they congeal on layers and they oppose this layer. So on the other side of this layer, it opposes the black. On the other side of the black, it opposes the red. On the other side of the red, it opposes the black. You get layer after layer after layer after layer called iron banding. And it's strictly because of the separation of the blood due to the polarities. All right, so that solves that. Now let's get back to business. Hold on one second. Let me turn the lights on. Camera, action. Here we go. Now, we're going to go back to our balls. There's some more. These are like Moki marbles. These are the little tiny ones that are in your skin. And I mean, there's so many of them you just can't even imagine. You can't even start to imagine. I'm serious. It's absolutely incredible. Now, this is another one. This has got to be in some kind of chemistry. I believe that's copper. But they're layered. Sometimes they're layered, sometimes they're not. Sometimes they have webbing in them. There's all kinds of different situations going on. Here's one with a hole in the center. Like, I don't know if that was vacant in there before it came to this situation, or there was some kind of goo in there. I don't know. But when they said the moon rang like a bell, I say it kind of jiggled like jello. Now, you're in space too. Don't forget now. You're not pushing against anything. You're just sort of making your own sort of thing happen. You know, if you're up against a wall or you're laying on a table and you ring it, there's a whole different story because you're pushing into another surface and it's dampening you very quickly. Out in space, there's no damper. So it goes boing, boing, boing. It's like one of those Newton's cradles, which I have over here. You go bang, it goes bang, 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 bang. You know, and on Earth, you got gravity pulling it down to stop it, but out in the moon, there's nothing there. There's nothing to bang against. Let me just put it that way. So I can easily account for that 5 hertz, 5 vibrations per second. You know, I do read the responses sometimes. You know, they're very nice. Most of them are very nice, but sometimes, who knows? But they're saying, "Oh, you rock, thank you," and that's very nice. And hopefully, now you'll be listened to. I hope so. Now, this was a question. I like questions. She said, probably an ignorant question. No, not at all. Why would this begin or become apparent now, which is the heat, when space is so very cold? What would cause the decomposition process now, assuming it's just started? Well, that's the case. It hasn't just started. It's extremely slow because it's anaerobic. There's no oxygen there. Anaerobic decomposition is very, very slow and gradual, and I think they just started looking for it in the first place. They just, for some reason, they were doing some reconnaissance out there looking for a signature of anything, apparently, and they saw some kind of a heat signature at these two craters. And you know, I've known right along what this is. It's a tendinenthesis. It is what it is. Of course, you know, how are you going to say this to somebody? They don't take you serious. They think you're an idiot. So, you know, what do? You keep saying it, and people keep saying you're an idiot. The only people that pay any attention are people like us that have questions, that think. That's rare, absolutely rare. And even like I think I might have mentioned already on 60 Minutes last night I was watching, they say college is nothing more than an echo chamber now. You can't speak. You're not allowed to have a thought of your own. It's an echo chamber, and all it is they're, you know, they're just literally stealing money from the kids now. These colleges is a waste of money, absolute total waste. I could teach you more here on YouTube for free than you will ever learn in any college anywhere, because most of what they're going to tell you has no basis in truth. If it's material evidence and we can examine it and discuss it, then we can determine if it's true or not. Right now you can't determine that because they will not let you discuss it. So anyway, I just thought I'd throw that in because for some reason but this is the question: how long does it take to decompose? It's going to take a very long time, and it's deep inside the body of the moon. So, is the moon cold inside? I don't know. I would assume it is. I would assume it would shed heat. That it was going to absorb heat from the sun. There's no question about that. It re-radiates. As a matter of fact, here's my little diagram. Here's the sun. Here's the corona of the sun, which is millions of degrees. It's only 10,000 on the surface. The reason it's millions out here because it's scrubbing and spinning through these particles in space. And they're heating up and radiating out and spitting out of here a zillion miles an hour. See this fast spin and this slow spin? This is like high energy. These are the blue ones. These are the red ones. Now, what is the moon doing? It's just re-radiating. It can never get past red. You know, it can't really radiate. When you get a good full, you know, harvest moon, a real glowy moon, it might exceed the red. I don't know, but it's a re-radiator. It is not. It's not emitting its own radiation. It's re-radiating. So it's absorbing and re-emitting. That's what you have to understand. We are getting direct hit. On this side, it's much cooler. At night, it's very cool. Well, not very cool, but it's a lot cooler. During the day, this is intense heated. Intense, because not only are we scrubbing through it, which we are on this side as well, so we're getting heat everywhere around from the scrub, but here it's increasing the heat exponentially from the radiation from the sun, adding to the ionosphere scrub. So not only is it scrubbing against all these other particles in space, this is pushing against that too. So you got a double scrub and a push and a scrub and a double. It's doing all kinds of stuff out there, and there's no vacuum out there. This is absolute insanity what we've been taught, and they continue to just spew it out. Webb telescope, we see billions of miles, we know it, and now the universe is expanding faster. It's actually accelerating. Why would it accelerate? It just means that we can see further, and it's getting slower and slower as it comes to us. Coming through all this stuff, there's no way in the world light stays the same speed. 100% certainty that it slows down. And there's no question they know this. How they are trying to act so incompetent, I have no idea. It's apparently it's to get funding. That's the only thing I can think. And they're willing to they have to be pretending to be this incompetent. It's just impossible. Impossible. Absolutely impossible. You know, this is what I'm talking about, how they can be so incompetent or pretend to be so incompetent. That's a foot. This is Stonehenge. That is a foot. It's called the heel stone. It's not where Stonehenge is, like 450 feet up the street. But it's a foot. And there was another one here. It was called a twin stone. Duh. These are toes, and at the end of the toes, they have the vein and the artery, which is where it transitions back, because the the artery ends and the vein pulls it back. This is exactly the structure of a foot, and that is a foot, and it lands flat on its side. You see this flat side? Click. That is the vein, and I'm sure you can find the artery blood here if you. It's probably right over in here somewhere. Now, I have these too. I have no toes. They're not the same as those. These are a different species. These are a different species. Now, this also died on its side right there. It died like that, flat on the side like that. And this is where the fibula just fell right off. And this is the front, just like this. It has a little thing here, because it had to move its toes up and down. I've shown this over and over. And this is where the tibia comes down, the main bone. You see that round spot right there? I'm sure you can see these things. Let me back that up. And this is just like a foot, only it's a new style. It's a different style. It has springs inside, I believe. We have other ones, and no question it has springs. And I believe this one does too. And they rock on that pin. And it's got a built-in sole. This is not a shoe. And that little round button on the front, you see that? When I saw that, I said, wow, what the hell is that? Now I understand it. That's the lock, which is going to be a spur lock. And it locks all the fabric together. See how the fabric comes in from all the way around there? And that pin right in the center pins this tab to lock all that fabric together. I thought it was like some kind of emblem or something, like Michael Jordan, Air Jordan, or whatever it was. Now, something else I wanted to show you. I mentioned that bones, like this bone, is as complete as it could possibly be. It's got all of the architecture. It's got the cartilage. Normally, you see a bone and it comes around this way and then around this way. It's like a regular bone you give to a dog, you know, that type of thing. You don't get the cartilage. You see that? This is cartilage. Now here's one without the cartilage. You see the same? You see the little flap down here? That's this flap right here. You see it? See that? Right there? That's this. Then up above, it must have fed right into the cartilage area or something, because all of this is cartilage. And that's gone. It would have come up around here, just like this one does. But it's gone. But they are basically the same. They're basically from the same size of a creature, but all the cartilage is missing. And on the other side, this one's just got bone. This one's right down to the bone. And I believe these are where the tendons lock in, I would imagine. Those three spots. Anyway, that's something we'll have to look at a later date. But this is not possible for these people to be this incompetent. This is my point. We're being taken advantage of by these. Look at this. These are all about stone balls. Here's ones on a stalk. You know, they have a stalk to them, just like I showed you the moon and all of them. And this one here is split because it is got a lot of blood in it, and it cracked open and just fell apart. That's the iron. Whoops, that's the iron banding. And this is a stone cutter. They're cutting stone. Like I said, whatever had a stone in it, this is Baalbek. You see these stones at Baalbek? I have the same thing here, only they're a little bit smaller. but these are the Baalbek stones. And that is nothing more than a tendon chunk. And I have exactly the identical same thing here. And they are glued at the end. Nobody cut these. They are broken, they break off just like this. I have the exact same thing here. And mine has muscle and a bone attached to it as well. And it has the glue is still there. And you see how this is stepped off? You see how this is stepped off right here? There's one coming this way. And it stepped off and one coming this way. They were here and then over here. So they're not the same distance. Now let me show you something that proves what I'm talking about. All right, you saw the Baalbek tendon. This is I believe this is from a shoulder, I'm not sure. But this would be where the bone is right up at the shoulder, let's say. And this is the glue, and that little pin, which is this pin here, this is the same piece, only the bone is missing. All we can see is the pin here. So this is that pin. And that comes down to this piece right here, which is the tendon. And you know, you got to be able to move your arm and your shoulder and all that stuff. So, but you need a tendon in between, and that's this. Now, this tendon is exactly the same as the Baalbek tendon. I'm going to show you, there's little pieces in here that are from the Baalbek tendon. Same exact same thing. There's glue in here. Now, between the glue and here, there is those tendon fibers. And what tendon fibers, Roger? Well, these tendon fibers. You see them? This is the glue that I talked about. These just break right off. They just snap right off just like this. They have these little things between them because normally they would have to move this way and that way. Remember I showed you the Baalbek ones were stepped off? See this? Stepped off. No difference whatsoever. Identical, right down to the color, the everything. It's 100% exactly identical, much smaller, but no difference whatsoever to the Baalbek stones. None, zero. You see how it's stepped off? And they have to do this and go like that. So they have to move all by themselves one way or the other. So they need a slip between them, and they call it a slurpee. It's a slippy stuff that goes in between them. And the crazy thing is, you want to see something funny? I'm looking up coefficients of friction the other day for something, I forget. Synovial joint in humans, this is the coefficient of friction, is 4 times slipperier than Teflon on Teflon. It's the slipperiest thing on the face of the planet. It's just amazing how it just cuts back on friction. But you need the right chemistry in there, and you need to keep it moving. That's the key. It'll set up in there, and if you don't keep that stuff moving on a daily basis, it'll harden up. And I've talked to autopsy guys, and they say they can tell when a person was in pain because their fascia wouldn't move. They had to cut it with a knife. Usually, they said you can open it up with your fingers like this. If your fascia is in good shape, it should be quite pliable. But when they get this guy that he was in serious pain during his life, and then he died, and then they do the autopsy, he's an anatomist, and they cut through there and they open it up, and they got to cut through with a knife, and then they can't even open it up. It's hard like a board. I mean, he said they can get hard as a board. You know, when I say hard as a board, they really can't stretch. And I had that happen to me. And I worked it out. And I did the way I did it, I just gradually moved my legs back and forth, laying flat on my back and pulling my legs up until it just began to feel uncomfortable. You make it hurt, you're going to make it worse. But you do that and you just hold it there. It's like yoga stuff. And the guy that I have worked with, he runs a fascia institute, and it's all about staying fluid. That's what the whole new movement about aging gracefully is, to keep your body active and move. That's why I say walk such and such. Well, that's good for you. That's fine. I believe that getting your fascia, you're moving your fascia when you're walking. Obviously, your arms are going, you're doing, you're walking, and your feet are flopping and all that stuff. Really, yes, excellent. when I was in the Army, they used to call it the Daily Dozen, where you had to do, your jumping jacks and all, I can't remember all, it was 12 different exercises. And you just do them, they're fairly simple. And that kept you in pretty good shape. So if you don't, see, I keep running off onto all kinds of things, but that'll get glued up between there if you don't stay in good shape. Let's just stop with that. I'm sorry, I can't help myself. I run into these things and everything ties together. So I just start rambling. There's a guy looking at a stone very similar to this. And, Vladimir, call me. We can talk about this. I know what this is. If you want to know, give me a call. We will talk. All right, I think this has gone long enough. This is Sam Aswagawa. She's over in Bosnia. And this is a giant stone ball. And if you look at it closely, it's got this stuff missing too. That thin skin of membrane is gone. Hey, how's it going, Sam? Now, this type here might ring a little slower. I don't know. This has some kind of webbing inside. Maybe it distorts and does that. No, I don't know. That's another tendon ball. Right there was where the anchor was. Maybe it's this style here, like the Moki marbles. They say that there's some kind of core to these things. Well, they don't have any clue at this moment. I mean, I'm serious. If they can't see what I have shown or even engage in discussing it, then I have no respect for their ability, and I have no respect for their ability anyway. That's just a fact. How can you respect somebody's ability who won't discuss something that they know that they're not right? I know they know they're not right now. It's just impossible not to know. Here's the Moki marbles. And these are the same things that are Mars blueberries. Identical. Mars, identical to Earth, identical. Only it got hit by Venus. Phew, case closed for them. It took us a while, ages in chaos, to come back after this devastating, almost direct impact. But it did recover, and now we are in trouble again. All right, now don't forget, I have DNA certified 3-foot long human fingertip. 3 feet long. Now, I don't know what the distance of these things are, but they're tendon blocks like this is. And they have this slurpy stuff on them. And they have, like right there is where the tendon slurpy stuff is. This is pretty much gone, slurped off. There's some you can see here. But this side has virtually none. Now, let me put this down. Oh. How long is that? I don't know. You tell me. Let's say it's 50 feet long. My guy would be 180 feet tall, approximately. All right? 180 feet, maybe a little more. Maybe a little less, but 3 foot long fingertip. You do figure it out. Because they were anatomically, it appears to me, exactly the same. How many guys would it take to carry one of those? I don't think that many. It's that's going to be heavy. It's probably going to take more than one guy. But I don't think it's out of the question. You get enough guys, they just pick it up and they carry it over and they put it wherever they want. Because here's where I was getting in trouble was pre-flood and post-flood. What was here before the flood and what happened after the flood? These things were before the flood. These weren't after the flood things. They were working with these things, I believe, before the flood with the pre-flood giants. They were working with these, which is the ones that I have. And they were killed during the Great Flood. So I'm going to leave it at this for today. And I'm sorry they're running so long. People are saying they're not upset that they're running long, but I do know that people have only a certain amount of time, so I'm going to let it at that. Anyway, I love you all. I'm hoping we can understand our true reality, and I'm hoping Trump can stand up to these bullies. You know, the academics, they are bullies. They are literally the biggest bullies on the face of the planet. They will destroy your life and go to sleep with a big smile on their face. They'll fail you if you refuse to say exactly what they say. And exactly what they said in 60 Minutes last night. They become nothing more than an echo chamber. If you don't repeat what you're told to repeat, they fail you, keep your money, and destroy your life. That doesn't sound like the most equitable system I have ever heard. Now, I give free information. You take it for what it's worth. But if you think your teachers have a better grasp on reality, well then, good for you. Good for you. GFY. Good for you. All right? Thank you. I love you all. Come down to reality. President Trump, Elon Musk, you got to do something here. And Musk's talking about cutting $2 trillion. I don't see any big problem with that. We just got to get rid of the fund grabbers. And that's all they're doing is running around spitting out money to their buddies. As far as I can determine, they won't take a look at anything. And I have every bit of scientific evidence that is literally, ethically, morally, and I think legally, they are responsible to examine. If they're making these statements as fiduciaries to their student that we're working in your best interest, but they won't allow any information that shows that they're wrong, that is not a good fiduciary, and I think that's a legal issue. So I'm hoping I can work with President Trump and Elon Musk. I have all the evidence. I have all the emails that goes back 10 years, more than 10 years. And primarily Yale University is the one I'd like to see get sued first. I got others. But Yale was the worst of the worst. And they have kept this back from people since. Oh, no, we published a paper. No, you published my paper. And kept it so it was very, very quiet on the surface. Yeah, guess what we found? It was before there was any life on Earth. They were just slimy, slippery creatures, which is what they want to show for evolution. These people are not honest. They're not being honest with us. And it's a search for funding, because at the exact same time when they failed to even talk to me, well, they talked to me, but they just said, oh, you just got rocks. Then I talked to NASA, said, you got the same stuff on Mars. They went to Yale, and they paid Yale to do a study, and he just basically used my work. There was Derek Briggs at Yale. If he says no, you show me where he did anything different than mine. The same story. Silica-rich oceans flooded the Earth, one worldwide layer of 3 layers, a red bed, gray clay, black cap, Triassic layer. That's what all my stuff is. And they are not just gooey things. And they are new species. And all of this was a new fossilization process. And they Briggs and all the rest of them, they agree with this now. And now they're taking credit for it. The most disgraceful people on the face of the planet, as far as I'm concerned. And I would like to see Yale just shutter them. Make it a place for the homeless. Get something out of that place. All right, I love you all. And I hope President Trump gets the word on this, because he's making a lot of statements, and so is Elon Musk. And I got a lot of things that I can work with him on. A lot of things. So my stuff is up on the internet. It's on YouTube, so anybody can go up and see it. But you have to search. You don't search, you're never going to find. All right, I love you all. Bye.